select the next triad. Hold on. Apply it. Okay. Boom. And so it auto-generated a triad at the center of the robot. You see the location is at the 0 point. Now we're going to grab it and move it. Boom. You see how it's changing that DCS zone as we sit here? We're going to take it that way. Just move it over there. And then we're going to use the triad location. Hit OK. Notice it's still in a flat plane like the original one that we did. It's because there's no Z value to this. So we're going to add an 800 here. And then we're also going to add a 2000 here as well. Boom. And as you can see, it generated a box right there. So this diagonal out is a DCS zone that if you breach this space here, that it is going to e-stop the robot. So we're going to have to apply these DCS parameters again. All right, now that we got our DCS zone applied, we're going to basically just demonstrate the same thing again. So we're going to shift reset, move in the not X direction, our axis 1, and then we're going to move forward until boom, there you go. Now the tooling has breached that diagonal out zone, and you can see the robot has e-stopped and faulted out. So that's the main difference between the diagonal ins and diagonal outs. It kind of wraps up the DCS, at least the basic DCS portion of this video. We'll be doing some other videos that goes a little bit deeper into like some more details, and we're just gonna have a lot more content. Eventually we want to show you guys like a 2D drawing and make our DCS zones based on those different CAD drawings to show you how these tools are really, really powerful. And whenever you have all the CAD data from like cell layout and all that good stuff, that you can more easily generate these DCS zones, and the big thing is more efficiently and more quickly and more safely. So if this video was useful for you guys, hit that subscribe button down below, and we'll catch you on the next one.